All right, here we got the point 4, 1, and we're trying to find a point in the fourth quadrant. So quadrants 1, 2, 3, 4, the fourth quadrant, that is the same distance from this point as it is from the axis. And the first time I did this, first time I looked at it, I'm like, that kind of stumped me. Well, actually, first time I looked at this, I screwed this up because for some reason I was reading third quadrant. I don't know why. I was like, oh, where am I going to find that? I don't think that exists. It doesn't. Anyways, so I saw, oh, fourth quadrant. It kind of stumped me for a minute, but then actually it's really easy because it's right here, right there. See, it's 1, 2, 3, 4 spaces from the axis, and 1, 2, 3, 4 spaces from that point. Pretty easy. But then, well, are there any other points that are the same distance from the axis as they are from the point y-axis, by the way? And actually, if you look here, there's several others that are not necessarily in the fourth quadrant, but right here, in the middle here, right, that's 2 spaces from the point, 2 spaces from the axis. And then I thought, well, there's this mirror image up here, 1, 2, 3, 4 up here. That point is also the same distance from the point, 4 spaces, as it is from the axis. You know. I thought, well, it looks like, I wonder if there are more. Maybe there's something in the middle here, down here. And then I thought, so how am I going to figure that out? And then I got it. Here's what we're going to do. I'll show you an example. I'm going to have you do one too. All right. So I'm going to let's pick a line here. I'll pick this one here. So let's think. Somewhere on this line, and this line is x equals 3. Somewhere on this line, let's assume that there's a point that is the same distance from this as is from the axis. So somewhere on this line here, like maybe right in the, because it looks like if here and here, maybe somewhere in the middle, there is a point that's the same distance from here straight to the axis as it is over this point. And how would we find that? Well, first of all, we'll set up a little distance formula problem here. But we also, wherever that point is, we don't have to find both coordinates. We only have to find the y coordinate because the x coordinate we know is going to be 3. And we know that its distance from the point 4, 1 has got to be 3 units because it's 3 units from the axis, right? So if it's 3 units from the axis, we want it to be 3 units from the point. We know the x coordinate is going to be 3, and we know that the overall distance is going to be 3. So let's set up a distance formula problem here. All right, so our distance to the point from our unknown point here, we use the distance formula. X sub 1 minus x sub 2 squared, y sub 1 minus y sub 2 squared. Now, we'll call this x sub 1, x sub 2. Okay? And our point over here, our mystery point over here is going to be, what's xy? What am I doing there? X sub 1, y sub 1. We'll call this x sub 2, y sub 2. It's not this point up here, but the point over on our line. Well, we know, actually, let's not write this all. We know that x sub 1 is 4 minus, and we know the x coordinate for x sub 2, that's going to be 3 because it's on this line, x equals 3. So 4 minus 3 squared plus, we know the y coordinate here is a 1 minus, then we got to find this other y coordinate. It's the only thing we don't know. Okay? And we know the overall distance, since we want it to be the same distance from here to that point as it is over to the line, and we know over to the line it's 3 units, so it's going to be a 3 in the end. So I have to solve this equation for y. So let's see. We have, switch colors here, 3. Let's see, this is just 4 minus 3. That's a 1, and 1 squared is 1, plus 1 minus, all right, there we go. And let's see now. So let's square both sides. 9 equals 1 plus 1 minus y sub 2 squared. Let's square both sides. Let's see, I will, we'll subtract 1 from each side. So that gives us 8 equals 1 minus y sub 2 squared. Now here's where a little trick, you got to watch out. We want to take the square root of both sides so that we can get rid of the squares. We're trying to zone in, like hone in on that y squared there. But if we take the square root, there are two possible answers. For example, like the square root of, let's just give you a number up here. Square root of 9 isn't just 3, right? Because negative 3, well, the square root of 9 technically is just 3 because that square root symbol applies to, it means the positive square root. But I guess if we're taking the square root of something, we have to keep in mind that we have negatives as well, because negative 3 squared is 9 in the same way that 3 squared is 9. Okay? So if I want to take the square root, be careful, there's a positive and negative version. So the way we do this is, I'm just going to say, sure, it's the square root of 8, but it's plus or minus. Okay? And then I can undo the square root part here, 1 minus y sub 2. So if I were to square, when I take the square root, I have to keep in mind there's positive and negatives. And then, let's see, well, this is a little bit tricky here. We're going to subtract 1 from each side. So let's see. So I'm going to put negative 1 plus or minus square root of 8 equals negative y sub 2. But I don't want negative y sub 2. I want positive y sub 2. So I'm just going to multiply everything by negative 1. So over here times negative 1 gives us a positive 1. And this plus or minus, that doesn't really change because plus, it just means it's going to change sign, but I've already got both signs. So plus or minus square root of 8 equals y sub 2. All right? So we have two potential answers here. 1 plus the square root of 8 and 1 minus the square root of 8. Let's get our calculator out here. Let's see what those values are. 1 plus second square root 8 is a minus, so it's a negative 1.8284. So negative 1.8284, or plus 1 plus square root of 8. That gives us 3.8284. Okay, 3.8284. All right, so let's see. 1.8, so negative 1.8. So it's going to be, the coordinates for the first one will be 3, and then negative 1.828, which is maybe close to 2, right? Somewhere around there. And that one was 3.82, so it's 1, 2, 3, you're kind of close to 4 there. So it looks like there's kind of a symmetry right there. Okay. So for you, I want you to find one, but I'm going to have you find one I think is a little bit easier than what I just did. But we'll be following the same method. So pause for 1 second. Okay, so your line is going to be out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 at x equals 10. Right. So you're going to set up your equation, and it's going to be, okay, so the whole distance needs to be 10 units away. So 10 equals our distance, so square root of, we know our x-coordinate for here is going to be 10, and our x-coordinate for here is 4. So plug that in. 10 minus 4 squared plus our y-coordinate, that's, unknown, y sub 2 minus, our y-coordinate here is 1. You'll notice I just noticed this now. I switched the order of the coordinates. So when I plugged them into the distance formula now, I went from unknown down to 4, 1, whereas before I went from 4, 1 out to unknown, but it doesn't really make a difference. Okay? So you got to solve this equation for y sub 2 to figure out what the coordinates is, and what coordinates for that point are. And this one, by the way, oh, this one's a whole number. So right? It'll be easy. Whole numbers, no weird square roots. Okay? All right, there you go.